Hey builders, today we're diving into the best practices for leveraging GPUs in Snowflake Notebooks to supercharge your machine learning workflows with Snowflake ML. Before we jump into the how, let's quickly cover why you would want to use GPUs in your Snowflake Notebooks. GPUs excel at handling compute-intensive frameworks like PyTorch. They're built for parallel processing, making them perfect for deep learning model and training and inference, processing unstructured data like images and videos, generating and working with embeddings, accelerating large language models. When your workflow involves these use cases, GPUs can reduce process time from hours to minutes. Let's start with how to access GPUs in your notebooks that run on container runtime, which is purposely built for large-scale ML development. When creating a new notebook, you'll need to select an image. Snowflake offers both CPU and GPU-enabled containers. For GPU loads, make sure to select a GPU-compatible image. After selecting your image, you'll need to configure your compute pool. This is where you define the GPU resources for your notebook. Based on the GPU type you need and have access to, you'll need to select the appropriate compute pool. Remember, the right configuration can make a significant difference in both performance and cost. How do you choose the right GPU configuration? Here are some guidelines. First, estimate the size of your data and complexity of your models. Then select a compute pool that fits your workload with these simple principles in mind. Choose a GPU size that can comfortably handle your data volume. Account for memory amplification. Data often requires 2 to 3 times more memory during processing. Consider going one size larger than your initial estimate to avoid out-of-memory errors. For iterative development, start smaller and scale up as needed. The right side balances performance with cost efficiency. Too small and you'll face memory errors. Too large and you'll be paying for unused resources. Now let's talk about monitoring your GPU usage and managing costs. In your notebook, there is an active monitor button that gives you a quick overview of resource utilization. Hover over it to see current GPU memory usage and compute statistics. For detailed information, you can run NVIDIA SMI commands directly in your notebook to get comprehensive GPU statistics. When it comes to cost, GPU consumes Snowflake credits at a higher rate than CPUs. You can find the exact rates in the credit consumption table in the Snowflake documentation. To optimize costs, manage your idle timeout settings. You can shorten timeouts for development work or extend them for long-running training jobs. When you're done with your GPU workload, make sure to properly end your session to avoid unnecessary charges. Click the End Session button to release GPU resources. This immediately stops credit consumption for your compute pool. Remember that idle sessions will eventually time out based on your settings, but manually ending sessions when you're done is the most cost-effective practice. Let's recap what we've learned. We learned how to select GPU-enabled images when creating notebooks for compute-intensive tasks. Choosing the right GPU size based on your data volume plus some overhead. Monitor resource usage with built-in tools and NVIDIA SMI commands. Manage costs by understanding credit consumption and ending sessions promptly. GPUs in Snowflake Notebooks gives you the power to tackle complex machine learning workflows right where your data lives. Make sure to check out snowflake.com/ML to learn more about our machine learning offerings. Helpful resources are linked in the description below. If you found this helpful, hit that subscribe button for more Snowflake tutorials. Happy building, and we'll see you next time.